Okay, let's go for the next experiment. It's gonna be the magnetic field, symbol P. Right. As we know, the magnetic field is created when we have charges in motion. Charges in motion produces the magnetic field. For example, imagine that we have a straight wire, we have current. So it's found right that current produces right a magnetic field. In this case, we use the right-hand rule to represent the direction of the magnetic field. If this is the direction of the current, right, the fingers crossed represent the direction of the magnetic field in that way. In case we have a loop, the same thing, right? Imagine that we have the current counterclockwise, so we have then the magnetic field is produced right in that way. Also, when we have a solenoid, right, we have many loops together, the same thing, right? So we have the creation of the magnetic field because of current. Today, let's plot the magnetic field. To do that, let's use a magnet. And how do we detect then a magnetic field? Well, let's do the same technique as we use for gravity and for the electric field. For example, for the gravitational field, we use a test mass to detect gravity. For the electric field, we use a test charge to detect the electric field. Now, for a magnetic field, we are supposed to use a test magnet. The test magnet that is used is the compass. So the compass is our test magnet, right, to plot, in this case, the magnetic field. Okay, great. For example, imagine that we have a bar magnet, right? And we take the compass. Imagine, for simplicity, that this is the compass, right? And this represents north and south, right? Now, if we place this compass right here, what happens? Well, it's going to be pointing in that direction. If we place the compass right here, right in that direction. If we place it right here, right in this direction, right here, right like that, correct? If we take all the points together, right, we create the direction of the magnetic field, right? That's the purpose for today, right? We have to use a compass and create, and let's trace right the path of each magnetic line to create the magnetic field of a magnet, like in this case, right? This represents the magnetic lines for a magnet, right? And let's try to do it today as an experiment. It's gonna be a very easy experiment. Okay, let's do it. Okay, let's go to the experiment. This is a demo. Imagine that we have this wire that represents straight wire, right? This one right here looks like it's straight, correct? Now let's create a current, placing a battery right here, right? And now let's see how the magnetic field looks like on this surface. Okay, let's do it. So we have the battery, right? We have the battery. This is the battery, right? This is the battery. Okay, in series. Okay, perfect. Let's create current through this straight wire, right? And now let's just sprinkle some iron fillings, right? This is iron fillings, correct? And let's see how is the magnetic field. Let's do it. See, they are coming in a straight line. Of course, we need more power, for more voltage to create better, more current to create a result. But you can see from here, right, that we have circles. The circles created, right, by the current. Can you see it? Kind of circles. Okay, great. Now let's go to a loop. Let's see what happens when we have loops. Okay, let's do it. The same thing, correct? Now let's connect the battery to this section for the loop. Great. This is the connection, right? And repeat the experiment, the demo actually. Okay, let's sprinkle some iron fillings. Correct. And now let's tap a little bit. You see it? Now we have the shape, right, of the magnetic field. Very nice, very nice. Perfect. Look, very nice. Very nice, right? Again, the magnetic fields are coming in circles around, in this case, the wire. Perfect. Now let's go to a solenoid, right? This is a solenoid right here. Let's see how the magnetic field is inside of this solenoid. Okay, let's do it. Again, let's connect the battery. Okay, the battery is connected. Now let's sprinkle some iron fillings. And see what happens right inside. Inside we have the concentration of the magnetic field. It's very strong and parallel. See? This is one of the ways how we can create a parallel right magnetic field. This is a solenoid. The interior of a solenoid. Can you see it? Perfect. Beautiful. Right? This is how it looks like inside. Great. Now let's go to a magnet. Let's find the magnetic field of a magnet. Yes, a magnet. To do that, we take a magnet, right? Let's take this magnet right here. Okay, let's place this magnet right on the bottom right here. Right, let's place this paper right here. Correct. Let's place it closer right here to see it better. Okay, great. Now let's just sprinkle some iron fillings, right, to see the magnetic field of this magnet. Can you see it? Wow, it's amazing. See, this is the magnetic field of a magnet. Perfect. Now let's do the case when we have two magnets, right? We're looking for the magnetic field between, let's say, North Pole and South Pole. Like in this case, correct? Imagine. Let's see what happens in this case. Right? Let's place this cardboard on the top. And then let's find the magnetic field in between. Got it? In this case, right, it looks like the magnetic field is joining, so we have attraction. We have one is north and one is south, so they attract. Okay, see, that's the picture when they attract. Perfect. Now let's reverse one of the poles, right, and look for the case when they repel. Okay, in this way. Can you see it? Okay, perfect. Let's go back again and repeat the demo. Okay, perfect. Let's do it. Right now, oops, they're so close, right? Okay, look, they move. Okay, let me align them again. Okay, let me repeat the demo. Okay, let's do it more carefully, like this. Okay, even goes like that. Okay, can you see it? Yes, you can see it. I can't believe it. Let me adjust the camera. Okay, perfect. Now this is the magnetic field in between these two poles. But now look, they repel, right? They repel. They are like this. The first case was like that, right? Now this is like that. They repel. Perfect. You see it when they repel? Yes, great. Now let's do then today, right, the experiment. To do that, we need a magnet. Right, this is the magnet that we are using today. Correct. Now let's place this piece of paper right like this. Correct. Imagine like this. Perfect. And now let's use the compass, right, and find the magnetic field right in both sides. Correct? Okay, let's do it. Imagine that we start by the center. These magnets are not so homogeneous, right? The magnetic field is not so nice like in the theory, but let's do it. So let's start at this position. Look, let's mark the initial, right, and final position right of the compass right here. Now let's move the compass, correct, and let's start one end of the compass at one of the points we drew before. See, and now we mark the other end. Let's continue like a continuation, right? Another point right here, right? And this is the first magnetic line. Okay, let's go to the other side. Imagine it's about the same distance from the magnet. Okay, let's mark the position right here, the other position of the compass right here, right? Let's move the compass and let's start with the last point that we draw. Imagine that's the case. Correct, that's the other point. Let's go to the next point, which is the one right here. Correct, can you see it? Hopefully, yes. Let's do it. And it goes like that, right? This point, this compass point match, let's say this point right there that we draw. Let's go to the next one like that. You see it? Perfect. Let's take another position, right? It's easier we start from the center. Imagine it's from the center of the magnet. Okay, let's wait until it becomes right stable. It takes for a while to find the 2 points, right, to give us the direction and position of the magnetic field. Okay, now let's mark where this compass is pointing, right, in that direction. Now let's go to one of the points right here, right? It may coincide the last point to again to the compass. Okay, and it looks like that's the next point, very close. Let's do it. Okay, it's gonna be right here. Let's go to the other side, right, and repeat, right, again. This is the way how we plot, one of the ways how we can plot, right, the magnetic field of a magnet, right? Now let's keep moving. Again, now this is the point right there. Let's make coincide right to the compass, very close. Okay, right there. Let's go to the other side, right, the same thing. Okay, let's make it coincide. It takes for a while to be adjusted, becomes a rest. Correct, because I'm moving it very fast, I'm shaking it, so it's kind of stable right now. Let's make sure that the closest one possible. Okay, it's oscillator on this point. Let's mark it, right? Let's do the same thing the other side, about the same distance. Imagine it's about the same distance from here and from here to the compass and from here to the magnet. Okay, the same thing. Let's repeat the procedure, right? We do this with a magnet and also with a solenoid, right? We apply current to a solenoid, right? It behaves as a compass. Actually, it behaves as a magnet, correct? And we call this electromagnet. Okay, perfect. Again, right here, look, these are the direction at that point, right, of the magnetic field. Again, let's go for the next point. Okay, the next point is gonna be kind of like this. Okay, let's make sure it's the closest one. Okay, more or less we have the next point right here, right? Let's go to closer to the magnet, correct? And we find the next point. The next point is coming, correct? The next point is gonna be around here, Okay, perfect. And then the next point, the final point. Okay, let's do it. Remember, the magnetic lines never cross, right? The same thing as for the electric field, right? The lines don't cross, right? The same thing happens right here. Okay, when we're dealing with the same object. Okay, perfect. See, now let's go around again and let's find the path, the direction, right, of the magnetic field. Again, it takes for a while until, right, the compass is adjusted, is at rest. Okay, more or less it's gonna be around here, the next point, right? Let's keep on doing it, the same thing as we did the whole process. Okay, so it's gonna be again the position for the last point. Finally, let's do the last one, right? Because we don't have enough room, right? It's enough. We have 3 lines, right, in both sides. So let's try to find that for the last line, 3, the third one. Okay, imagine that that's correct. That is already stable, right? Okay, let's mark again the direction. One point is, okay, it's oscillating a little bit. Let's wait for a while. Okay, now this one is at rest. Okay, right there. Again, you have a magnet, you have a compass in your home with you. You can repeat this experiment. It's a very nice experiment, correct? Okay, now let's again go down. Okay, let's start again in the last point. Okay, remember later you have to join all the points, but please don't go in zigzag. Must be a smooth curve, Okay, so the points are right here. 1 point, right? We have again the next point is coming. Okay, let's wait for a while. Okay, the next point is coming, correct? Okay, now let's see what do we have. Okay, we have the next point is right here, right? Let's go around to the next point right here, correct? Okay, perfect. So it's coming, the next one. I can't believe it. Okay, imagine that the point is, it looks like around here. They make it faster because I don't have too much battery in my cell phone. I just check. Okay, let me hurry a little bit faster. Okay, hurry. Okay, the next point is around here. And finally the last point. Let me see if I have room. Yeah, I have room. Okay, looks like it's gonna be right here. Perfect. Let's go around to this point right here. I marked it already? I think so, right? I did it. Yeah, I did it, right? I did it. Okay, let's go to the last one right here. Over the same distance to match, right? To make a very asymmetric magnetic field. Sorry. Okay, let's find. Okay, done. Great. Let's mark it right here. Let's mark it right here. Perfect. Now let's go down in this direction. Okay, great. Okay, the next point is coming. Looks like it's around here. Okay, let's continue doing it. Right. The next point is very close to this position right here, right? And finally, right, we have the last point, correct, around here. Correct. Okay, let's go to the other side. Okay. Let's align it. It's gonna be kind of weird. The last one, look, it looks like it was no symmetric. Okay, it takes for a while until we get the compass to be at rest, not moving. Okay, imagine it's oscillating around this point. Okay, let's make it faster. Okay, now look, oh my god, the turn's gonna be long turn right here. Wow, okay, let's see what happens. Okay, the next point's around here. Oh my god, I have enough, oh my god. Now let me mark it outside right here, okay. Okay, let me go back. Hopefully, yeah. Oh my god, I have not enough room right here for the last one. I can't believe it. Okay, the next point looks like it's gonna be right around here. Okay, let's go back. Look, wow, I can't believe it. And the next one looks like it's around here. Okay, see this, the last one looks weird for the magnet, correct? Well, let's use this line to approx right this magnetic line. Again, later you have to make a smooth curve, right? A smooth curve like this, connect all the points in the same way we did for the electric field, right? The smooth curve like this, don't go on zigzag. Okay, the smooth curves, right? Like also this one, a smooth curve. Doesn't matter if you don't touch all the points. Must be smooth, right? A smooth curves like that, and that's gonna be the magnetic field. Okay, and with this we finish this experiment. Okay, see you in the next one. Bye.